Hi, on this video we are going to understand what dimensionality is, this mysterious word that is blocking us to understand more about the theory of interaction. Why is important to understand dimensionality? Okay, dimensionality is essential to be studied if we want to understand why interactions are dimensional transactions. To simplify things, we need to conceptualize the dimensionality in a form that is compatible with all existing definitions and that we can apply to all systems. Not under the systemic point of view, the objective point of view, but under the subjective point of view. That is the natural point of view, the interactional point of view. We've said that natural entities understand environment in a subjective way. This is very important for nature. From the point of view of bacteria, some matter that could cause us disgust may mean the best nutritional source. So, bacteria are able to transform that disgusting matter into other products we may need. For example, bacteria are used to produce antibiotics, vitamins, etc. So, bacteria act as a transformer of matter. Trees are transformers of carbon dioxide into oxygen. Cows are transformers of pasture into milk. You can say any type of definition. Nature uses this approach, not the formal approach, not the systemic global approach, but the subjective approach. You can say that the bread baker on the corner of the street is a system that transforms coins into bread. So, in this weird example, the baker is a dimensional transformer. It converts a piece of metal with a value that is also subjective. If it would be objective, if it would have the same value for you and for the baker, then you would not buy bread. But you can't eat coins. For you, the bread has more value, and for the baker, the bread has less value. So, the baker converts a coin into bread. Bread and coins are two completely different dimensions, and that's what you need to, and what you need is your money to be converted to bread, not you need to find a baker. You need to interact. Only by interacting you can do that. It's the same for mathematical systems, for ideal systems. If we observe the free fall of an object, and we need to know how long will it take to fall 100 meters, we need to find a transformer, an equation that converts the time dimension into positional dimension. Converting coins into bread is the same. We use a system for that, and it converts a value in one dimension to a value on another. But it seems that the money value is a simpler linear dimension. It's not so linear. There are taxes to pay if you have money and more taxes if you don't. We said that it seems that the money value is a simpler linear dimension, but the bread is a mess of incongruent dimensions. There are weights, nutritional values, minerals, humidity, a lot of things that are mixed, and we can't observe in a unique pure dimension. Only energy could represent that, but if you eat a battery with the same energy value, it will not serve you as a nice partner for the breakfast. It will only kill you. How can we understand this mix of dimensions that the bread has? How can we idealize it to put inside a system? Uh, the first thing to notice is that in mathematics we use pure dimensions. The x dimension should be completely independent of the y dimension. If we draw a Cartesian plane with some inclination on the vertical axis, then the y-axis, the vertical axis, will represent values that contain a small fraction of x. This is not ideal in mathematics, but in nature it happens. Some dimensions can contain others. In fact, this is a property that's called hyperdimensionality and has a lot to do with synergy. What is synergy? When two or more systems interact with the environment, they cause a result on the environment. But if they act while having internal interaction, while having interactions between them, they add a new value to the result produced to the environment. For example, If you lift something with two sticks, one above the other, you can lift X kilograms. But if you put an adhesive between the sticks, you will lift more than X kilograms. So synergy is the result of the increase of interactions that occurs when many systems act together. And back to dimensionality. If we have three atoms, they are just that. But if they interact forming a molecule, the molecule gains synergy, gains new properties, therefore gains new dimensions. Just join some molecules interacting in a complex way and you will have a cell with a huge number of properties, dimensions. So entities are just dimensional transformers between dimensions. Whether they are pure or mixed, compound or maybe messy, but nature works as this. Let's begin with a simple example. We will use a mathematical system, an equation to convert values between two dimensions. Let's say that y equals 2x. In mathematics, this means that x equals y divided by 2. From the interactional point of view, we can draw the Idor cycle. The cycle that represents an interaction is called the Idor cycle. We can draw the cycle to represent the conversion of a value on the dimension x to the dimension y. In this case, if we put 2 units of x, we will get 4 units of y on the lower side of the transformer. We've said also that in nature, this normally does not work on the opposite direction. But in math, we can put 2 units of y and we will get 1 unit of x on the upper side of the transformer. It's moreover a linguistic issue, I would say. Let's draw this in a Cartesian coordinates plane. If we put 2 units of x, we will get 4 units of y on this direction. And if we put 2 units of y, we will get 1 unit of x on this direction. For systems of higher complexity, I don't like the expression complex systems that are used in universities. The complex systems theory, due to its a distortion of the concept of system. For some academics, a rock is not a complex system, an atom is not a complex system. Rocks were the main source of inspiration of the theory of interaction. Rocks, water, fire are some of the most amazing and complicated systems with capabilities of emergence, non-linearity, even cooperativity and competition behaviors. But we cannot understand this under the light only of the systems theory. We need the subjectivity approach of the theory of interaction. In fact, there is a criticism about the usage of the word general on the expression general systems theory. We cannot have a general systems theory different from a systems theory. We cannot have a complex systems theory different from the systems theory. So when I use the word complex, please understand that I don't use it in the sense of complex systems. I always mean just complexity. We were saying that for systems of higher complexity, the input is this rich mess of dimensional values, and the output is as complex as this. An equation is the system that can transform the energy value of the input and output, but it does not work with compound sets of dimensions. This would make math impossible. It will generate huge equations impossible to solve in a lifetime. But the natural systems are exactly that. They are systems capable of using internal properties and transforming a complex input into a complex different output. But a baker cannot transform money into milk, for example. Each system has a limited set of capabilities to transform things. Try giving coins to a cow and see if she is able to convert them into milk. Well, you don't need to try. The cow cannot do it. So here's the definition that would make us possible to use the concept of dimension not only on mathematical systems, but also on all systems, on natural systems, on ideal systems. A dimension is an approach of contents processing. Approach of contents processing. This definition is the definition that better resembles the natural dimensional transformation. For example, a distance, a value in the x coordinate is a measure between 2 points. Measure between 2 points. Here the word measure is the process. 2 points are the contents, and the approach is the actual measuring. Here we have the approach, the contents, the processing. Therefore, the x dimension is just a measure of distance between points, an approach of contents processing. In this case, the dimension y is similar, but it's not the same. The points are not the same, the measure is not the same, and the most important thing, the approach is not the same. The y dimension is completely different to the x dimension. But this is not only the way of measuring a distance. We can measure the distance with curved lines, with the fingers, with our hands, with our arms, with sounds. In fact, bats measure distances with sounds. Fish measure distances in function of corners and rock references. Cats measure distances in function of time and duration of memory, that in cats is really small. Let's see more examples. For a bat, a distance is a valuation of the time it takes for the sound to return back when listening. So the content, the approach is the listening, the content is the time lapse, and the processing is the mental measurement that is done by the bat. Another example, magnetism. Magnetism is a measure that's the processing, the measure of attraction, that's the content. The measure of attraction when two magnetic entities get near, that's the approach. For example, wind. Wind can be the impact, that's the processing, caused by the air, that's the content. Our bodies exposed to it, the approach is exposing bodies to the wind. Please notice that we are going from simple, ideal concepts of dimension to more and more complex types of dimensions. If we observe milk from the human point of view, milk can be the nutritional value, that's the processing, assigning subjectively the nutritional value, something that our stomach does when digesting and absorbing nutrients, that is obtained from this white liquid. The milk nutritional properties are the content for our body, caused by its ingestion. The approach is ingesting it. So we have a definition of dimensionality that reaches all levels. And here we should notice that dimensionality can also be subjective, as all other features on the theory of interaction. The approach is related to the entity that sends the stimulus, that you when you pay the bread, and receiving the reaction, you when you get the bread. Approach is related to the subjective process you use. This is the actual processing, executing the approach and the content. Well, it's obvious. For example, see this equation: x equals 2 plus 2 times 2. The answer to this equation can be 2 plus 2 equals 4 times 4 equals 8. So it can be 8, or if we take into account precedence of multiplication, then it's 2 times 2 equals 4 plus 2 equals 6. So we have two different results of this equation. This is a way of understanding that the processing can be subjective. Even in math, this can be 6 for a lot of people or 8 to a lot of people. It is subjective. Well, not for computer geeks. They use the convention of prioritizing multiplication. When we have convention, it's clear, the result is clear. Dimensions in nature are not pure, but not only that, they can mix different levels of existence, as we said. A tree does not absorb only energy, it requires energy codified into water molecules, CO2, mineral particles, and it can generate glucose that for some animals can mean a sweet snack. Dimensions are not pure at all. Now, why does natural systems do this kind of transformation? Natural entities just entities just profit of opportunities. For example, you may think, oh, there is no bakery in this southern French neighborhood. That is absolutely unacceptable. This is a golden opportunity, and you open a bakery, and that, of course, gives you an excellent profit. Atoms, molecules, etc., act in the same way. They profit of opportunities. Well, there are animals that require oxygen. Okay, here you have. What I need is CO2, or even more. There are no partner for this lonely couple of hydrogen atoms. I am an oxygen atom, and I need to form a couple. I need to have a family to interact with, to live my infinite life with. So please come, join me to form a molecule of water, so we can profit of another opportunity. There's a sea near here, and we will interact with other molecules, and we will be able to make transformations. Salt rocks into particles, for example, liquid rock into solid rock, porous rock into stronger rock. But come on, I need you, you lovely couple of hydrogen atoms, because I'm alone. I will not be able to do that alone. Well, that's a joke, but in fact, this is reality. See you in the next video. We will learn what chaos is and what is order. We will learn how the systems acquire order and why they enter into chaos. Maybe you've already the answer, yes, by interacting. Thanks. Please visit idor.org.